Hello, this is David Hall of the M2M Zone, and it is my pleasure to welcome you all to the M2M Zone webinar titled IoT Makes the Leap to Next Generation Cellular Networks. This webinar is sponsored by Digi International. Before we start, there are a few items that I would like to bring to the attention of our viewers. Today's presentation will be approximately 45 minutes long, followed by a 15-minute Q&A session with our panelists. This is an interactive webinar, so we are eager to receive your questions at any time. Just type them into the Q&A window at the bottom of your screen. Our speakers will address as many of the questions as possible during the Q&A segment following the presentations. Please address your questions to all panelists, which is the default setting in the Q&A box. This presentation will be archived and available for viewing later on in the events section of the M2M Zone website. Also, if anyone would like to see more details in the slides, simply click on the full screen button at the upper right-hand corner. At this point, it is my pleasure to turn the session over to our moderator, Robin Duke-Woolley, founder and CEO of Beecham Research. Robin has over 35 years' experience in the telecom and IT industry, firstly in commercial roles covering marketing management, sales management, and general management in international technology vendor companies, and secondly in market analysis and consulting roles. He has been researching the M2M and IoT market since 2001 and is an internationally recognized thought leader in this area. Robin?
Thank you, David. Well, we've got a great discussion for you today. We have two speakers with us to discuss next generation networks for IoT. Just to take you back, I remember a time some years ago now when I was asked an M2M module supplier if they could see a need for 3G speeds in M2M, and the answer I got then was no. So times have changed somewhat since then. In this webinar, we'll be discussing the sort of IoT applications that are best suited to 4G, LTE, 5G, carrier networks, and the market opportunities for those, now a crucial subject for the development of the IoT. So let me introduce you to our two speakers in turn, both from Digi. So we have Andrew Lund, who is product marketing manager, Digi International. So Andrew, are you there?
I'm here. Good day.
Great, must have been on mute. And Brent Nelson, who is senior product manager, Digi International. So welcome, Brent.
Thank you, Robin, and thanks everybody for joining.
Great. So, gentlemen, welcome to you both. Andrew focuses primarily on the retail, energy, and transportation industries. He manages Digi's 2G network, sunsetting activities or initiatives, and the go-to-market strategy for Digi's associated product solutions, including the Digi Transport family of M2M routers with Gobi 4G LTE technology. And then Brent has over a decade of experience in wireless machine-to-machine communication as a design engineer and product manager. As a cellular-focused product manager, Brent understands and constantly studies dynamics in the industrial IoT market. And with that knowledge, he ensures the Digi's cellular product suite addresses top industry challenges. Now, I'm going to present some introductory slides first, and then that's going to be followed by Andrew and then Brent. So just to remind you, as David said just now, there will be a Q&A session at the end. You can ask me your questions for our speakers at any time starting now. Just type them in the Ask a Question window on your screen. I'll put as many of those questions as possible to our speakers later in the hour. So please start sending your questions right now. So I'm going to do a short introductory few slides to just to sort of set the scene, and then I'll hand over, as I say, to Andrew. So IoT makes the leap to next generation cellular networks. Now, I always start my presentations with this slide, simply to remind us in this case that there are an awful lot of applications out there for M2M and IoT, and it's quite likely that one connectivity type cannot really cover all of these. And in fact, what we look at now is cellular, 2G, 3G, 4G, moving to 5G, Wi-Fi, Bluetooth and Zigbee, fixed broadband, wireless broadband, satellite, and now, of course, we've got low power wide area, the low power IoT, and also mobile IoT. So in the next few slides, when I'm talking about LPWA, low power wide area, I'm including, and in fact mainly talking about LTE and NB-IoT, which are the cellular versions of that technology set, if you like. So there are many different technology or connectivity types have a part to play in IoT. I think that's increasingly the case over time. Gone are the days where we just had 2G, for example, for most of what we were doing. So it's getting quite exciting now, and this is what we're going to be talking about. So just to remind those that may not be familiar, LPWA fits the area of data rate below cellular, below Zigbee, but higher range towards the longer range. So it's a whole opportunity for applications that have not really been feasible before, not really been economic to cover before, as well as providing, in a lot of cases, more economic way to look at some applications that have been looked at but perhaps not expanded on. So there's a lot of opportunity to start to get some real volumes into the marketplace with these technologies. This slide tries to summarize them into 7 different categories. So smart city, agriculture and environment, utilities, industrial, logistics, smart building, consumer and medical. So these are all, if you like, subcategories of the first slide that I showed, but all areas that have been difficult to use the current technologies or the previous technologies before we've got to the new LPWA area. So then just to remind us how LPWA is complementary to traditional cellular. So in the top one, in the top table, we have a comparison between cellular and LPWA. So energy requirements tend to be high with cellular, low with LPWA, and low with the mobile IoT versions of cellular. The range is long in both cases. The data rate is high for cellular, and of course getting higher with 4G to 5G and so forth, and that's going to be talked about shortly, and low to medium with LPWAN. Cost of endpoints, medium to high for cellular, very low for LPWA. In-building penetration is average to poor with cellular, but good with LPWA. So a big contrast there. And then application example, very easy one to visualize in the car park environment. So cellular would tend to be into parking payment systems, security, video cameras, and other high data rate applications. Whereas for the LPWA, we're looking at parking space sensors showing empty, vacant, EV charging availability, those types of things. So it's a complementary type of area. We did a chart to show how LPWA fits into the overall sector chart that I showed just now. So we flipped it up on its side, and then looked at, it's like looking under the bonnet really, looking at LPWA underneath that, and the types of activities, the types of applications that are already served by LPWA. And this is a whole new area that needs to be addressed by the IoT industry over the next few years. So when we start to talk about new volumes in the marketplace, we're really talking about the big volumes being in this area and through applications that have not really been covered in any great depth up to now. Then we talk about the service attributes for these type of applications? What are the main requirements? And I've listed those in this slide. So typically, battery life is important to consider. Transmit mode, whether it needs to be one-way or two-way. Message delivery, whether there needs to be some sort of acknowledgement of receipt. Latency. Scalability, can it scale to have huge volumes? Data rate, what data rate is actually required by the application? Geographic coverage, is it required in a national or even a country, a citywide type of situation, or international? Security requirements, what sort of security requirements does that particular application have? And then the device cost, very important. So some of these are probably more important than others, but those are the ones that we think people need to bear in mind. So now going to, did anybody see those slides? I'm not sure that I did. I'm sorry, but I'm having some difficulty with the slides.
Yes, Robin, we can see your slides advancing.
Okay. I'm going to hand over to Andrew now so that he can move through his slides.
Fantastic. Thank you, Robin. Let me get mine teed up.
Okay.
I trust you can all see those.
Yeah, I can.
Great. Well, good morning, good afternoon, and I certainly echo Robin's gratitude to our audience for joining us. Brent and I are excited to cover some material related to this notion that IoT making the leap to next generation cellular networks. There are many changes on the horizon, and it's an exciting time to be involved. I think that's the reason we have so many of you on the call this morning. Just a quick outline of what we'll cover today. I'm going to sort of provide an analogy or a metaphor to sort of frame the discussion around the notion of 5G and then the LPWAN technology that Robin was talking about. And then we'll talk about this notion of whether more or better sort of connectivity will be kind of the thing to focus on in the next few years, and then provide a little bit of a conclusion and wrap things up. And hopefully, as Robin said, we have some questions to drive some dialogue there towards the end. So Robin was sort of casting a vision of a pretty comprehensive vision, really, of different applications that are handled by different types of cellular technology today and have been historically. And we're on the cusp of a significant change. And what it sort of reminds me of is this is before my birth, full disclaimer, but in the mid-'70s, there was an oil embargo on the United States. And so there's an oil crisis, if you like. And the U.S. Congress enacted the National Maximum Speed Limit Law, limiting speeds on the highways, interstate highways, to 55, and that should be less than 55. And this was the motivation, I guess, for Sammy Hagar's famous rock song, "I Can't Drive 55." But basically, what Congress was trying to do is to limit oil consumption, and that's interesting and I guess kind of an interesting anecdote. But think about now today, of course, obviously it's been repealed, and it was done repealed in 1995. So the similarity that I would draw between that story and ours today is think about if you were shopping for a car in the mid-'90s and you knew that the speed limit was going to be removed. What would you buy? Would you buy a big muscle car to take advantage of what is it in Nebraska now? I guess it's like 75 or something, 80, I believe. If you knew a change was coming, you would plan accordingly, right? And so the answer to that question, what would you buy, really is it depends, right? It depends. Are you an over-the-road trucker? Are you a speed freak who likes muscle cars, let's say? You would want to make a decision for that transport based on what your application was, right? So it's the same thing with 5G, right? It depends. And so as we look forward, it's I think a helpful analogy to say that it's not just speed limit is being removed, but the shoulders of the highway, if you like, are being opened up for traffic. And so this diagram is sort of illustrating that notion that there's going to be a fast lane. There's going to be a relatively slow lane. It's not a perfect analogy, but it's accurate enough. And then there's going to be this kind of other, and that's what I would consider the unlicensed LPWA. And Brett will talk a little bit about those in more detail. But that's kind of the driving metaphor that we're using for today's discussion. And so with that, let me pass the ball, so to speak, to Brent to walk through some slides.
All right, thank you, Andrew. So to kind of follow up on Andrew's analogy, you know, we're getting off the freeway here with the narrowband, and we're getting onto the shoulders. In fact, we're getting onto the sidewalks, where you're talking about lower speeds, lower power type devices. So I'm going to talk about the narrowband, the new narrowband standards that are coming out for cellular. And when I say narrowband, I mean that's literally what it is. You're taking the 20 megahertz standard LTE band, and you're shrinking that down to a smaller band. And there's a lot of benefits that come with that. So I'm going to lump two different LTE standards under the category of narrowband. One is LTE Cat M, and the other is narrowband IoT. And I'll talk a little bit about the differences here, but in general, the benefits that they're going to provide and the way that they're going to expand the IoT marketplace are very similar. So when we look at devices and applications that don't need a lot of data, they don't need they need to be very low cost, they're running off battery, they need to be very low battery life. There's a lot of benefits to this. So with these new standards, you're going to see a lower device cost. You're also typically going to see a lower recurring cost with these devices. So that's going to be your monthly cellular bill that you're getting from your carrier. They're also greatly extended battery life and then improved coverage. Now the trade-off to that, and there's always trade-offs with everything, nothing in life is free, is you're giving up your latency. You're going to have a much longer latency with these, and you're lowering your throughput. So you got to think about the different applications where this could be of value, say where you're monitoring a sensor and it's sending very, very low data, very, very low data rates, and latency isn't as critical. So tracking things like tank levels or water level in a sewer or location of different assets. These are the things where these types of standards will be a good fit. So at a high level, this is a fairly technical slide, and I don't want to get too technical in this, but I do want to talk about the differences between these standards, because for the rest of the discussion, I'm going to talk mainly about them as a whole, just as narrowband as a whole. So Cat M1 currently being piloted in the U.S. So Verizon and AT&T have their pilot sites up, and they are testing out their Cat M1 networks, and you're going to hear a lot about this throughout the year if you haven't heard about it already. It's going to be starting to see those networks deployed more widely in the middle of the year and through the second half of the year. Now, in other parts of the world, NB-IoT is actually going to come to market first ahead of Cat M1. So Vodafone and Telefonica, for example, are doing their NB-IoT networks first. So depending on where you are in the world, you might see different networks that they're going to come online first. And then there will likely be devices that have global support and modules that will support both of these standards. So if you dig into kind of the technical details, Cat M1 from a downlink speed is sub 1 megabyte per second. And so think of like a 2G speed. Go back to the 2G devices that you had before. That's relatively what you get with Cat M1. Now, narrowband IoT even goes below that. So very, very low data rate. Again, think of a sensor just spitting out temperature data every 5 minutes. So very, very low data rate devices. If you jump down a couple of lines, you'll see module costs come down significantly, where you're probably paying somewhere $60 to $30 for an LTE module today, depending on how many different bands it's covering. The goal is for these types of modules to get down in the $10 and even sub $10 cost range. The other thing to note at the very bottom there is the different module complexity, and that's really where your cost savings come from. It's not an exact science, but it's it's a stat that's quoted a lot, is comparing the module complexity of these modules versus what you're getting in your LTE modules today. And that's where a lot of your cost savings is coming from. You also notice that both of these are running in half duplex mode, which is going to not only simplify the module, but that's where you're starting to make your latency trade-offs. Okay, so some of the So one of the biggest factors and one of the driving forces for involving these new standards is new power saving modes. So with especially in the industrial IoT market, you see devices that are installed in very remote locations, down in sewers, up in towers, places where you might need to drive 100 miles to go out and get it. You might need to go into a hazardous area to get it, and you might have devices that are spread out over hundreds and hundreds of miles. So battery life is a very, very critical thing for these devices. Where we're at today with LTE Cat 1 is about 2 to 3 years, and this is all relative battery life. It's all application dependent. How often are these devices collecting data? How often are they reporting? But a typical use case on an LTE industrial IoT device is about 2 to 3 years today. As we look and expand relatively, the LTE Cat M1 can get that to 5 to 7 years. And the narrowband IoT can take that up to about 7 to 10 years. And so what these new standards are implementing is a new power saving mode. And probably the easiest way to understand that, if you've ever worked with any machine-to-machine cellular routers or cellular devices, you power them up, and somewhere on that device there's probably an LED, and that LED flashes red for about 30 seconds while that device is connecting, and then it connects and it starts flashing green. Or green or blue or whatever color it is that indicate that that device is connected. I've watched thousands of devices do this over the years. And during that whole time, you're burning power. So what you really need is something that can stay sleeping most of the time and then connect and be transmitting immediately. So in these new power saving modes, devices can essentially, at least from a cellular module perspective, be off. But they're still from a network perspective connected, which means they can wake up and transmit at any time. From a receive capability, they go into what's called a discontinuous reception mode, which means essentially I'm not listening for traffic all the time. I'm going to wake up occasionally and look and see if there's any traffic or anything that I need to receive. And the key is that the network itself does not kick you off the network when you're in that mode. So this is really a software update that these carriers are making so that the device can stay connected even though it's really not even on at that time. So what you're doing here is you're trading latency for battery life. So when you think of your applications where latency is not a key factor, but battery life is, these are the standards that are really going to expand adoption throughout the market. So the second thing that's going to greatly expand the adoption of industrial IoT is the cost reduction. So these are the upfront cost reductions and the device cost reductions and the recurring cost reductions. Because everything, no matter how cool technology is, everything somewhere comes down to a return on investment calculation, especially in industrial IoT. If that return on investment calculation doesn't turn green, you're not making a sale today. So how do we get that cost reduction? So the biggest one is the upfront device cost. One thing to note is when you go to these newer narrowband standards, you go from a dual antenna requirement to a single antenna requirement without losing any of your coverage. So that alone is bringing down your antenna cost. I already spoke about the reduced module complexity, which brings down the module cost to the $10 and even potentially sub $10 range. So you're getting LTE at less than 2G prices. And depending on your application, you either get longer battery life or you can potentially use a smaller battery at a smaller cost. And cost is more of a factor than battery life. Now then there's the recurring data piece, which again is the bill that you're paying typically to your carriers. Some of that is going to come down just because you're using lower data usage. The second piece will be the reduced plan rates from the carriers. Now, I can't guarantee that AT&T and Verizon or whoever your carrier is going to give you a drastic reduction on the plan, but we understand the competitive nature of the market that they're going to be trying to get more and more of this industrial IoT and IoT markets because the consumer uses are saturated. So that's going to bring down those competitive nature, and the efficiency of these LTE standards are going to bring down that monthly data cost. Okay, so if we look at what does that really do to the market, and we look at the two approaches for connecting remote assets. Those assets, in this case, I'm using a sensor. They could be sensors, they could be simple machines, they could be complex machines. There's really two approaches to doing this today. Now, the one on the left is where you take a local area network, something 802.15 based usually, maybe Zigbee, and you connect those through a gateway. So each one of those sensors would have some kind of short-range wireless. They might be talking, I show kind of a very simple star network here, but that might be a very, very complex mesh network. And this has historically been the way that customers have gone to market, where you've got a lot of devices in an area and connect them through the central gateway. And the reason for that was the cellular modules were very expensive, so you didn't want to burden all your sensor costs with those modules. And also the data plan on each gateway could be very expensive. Now, the downfall to this is they're more complex to set up and maintain. Now, if we go to the right, which is really the Cellular Everywhere model, and that's where you're putting, in all your assets, you have direct cellular communication. That might be from a module inside the device, or it might be that device connected to a central gate or to a single gateway. But the point is that each one has its own cellular connection. So the benefit to that is the setup is very easy. You don't have local RF to worry about. You don't have to have a network engineer. You don't have to worry about somebody building a steel shed in between two of your points and having half your nodes drop off the network. But this has been limited in the past because of the cost of cellular and the cost of those data plans. And you saw much more of people implementing the type of topology you see on the left. But as we look at what's changing with these new IoT standards, it's really driving the market to cellular everywhere. And at Digi, we're not biased in this. We support both modes. So we're not biased in driving you one way or another. We're just kind of looking at what the market is trending. So really, we had a lot of customers who were doing the other approach with a local Zigbee network connecting to a central gateway, but they started coming to us and saying, with the cost that we're getting per device for our cellular data contracts, with the cost of those cellular data devices, either a module or an external gateway coming down so low, we just want to do cellular everywhere. We don't want to deal with Zigbee networks and other local RF. We just want to put cellular everywhere and make it easy to connect our devices. So this is where we start to see the market going with industrial IoT and these narrowband standards. Again, due to the dropping recurring costs, the module cost, also the fact that they're lower power, so it's less of a hit on the battery, either inside these devices or in the gateway. And really, it eliminates the need for specialized staffing because cellular is very easy to configure. They can almost be drop-in where you configure, they show up on site already activated on the network, and it essentially becomes just plug and play. So as these standards become more prevalent, we're going to see more and more people driving to the cellular everywhere model. Okay, I'm going to hand it back to Andrew, who's going to cover the remaining parts of the presentation.
Fantastic. Thank you. Okay, so as Brent said, we'll cover the rest of the material now, and as you can see on this section slide, what we'll be talking about are some real-world applications. And so, there are really no shortage of reports, of analysis, of conferences and speakers that you can go to and consume information in the abstract about IoT applications, right? But you're on a webinar now with a couple of product managers from Digi, and so we'll talk in a little more real-world application type terms, okay? And certainly we have no better source for the sort of analysis and comprehensive view than our host, Robin's organization with Feature and Research. But we'll cover some specific things now. Earlier, I mentioned this concept of making a distinction between more connected things and better connected things. And so at Digi, our focus is on what we call sort of mission-critical IoT. And so I'll be explaining that as we go through, but just what do I mean by better? Start off with that. What do we mean by better? So better means faster in terms of throughput, low power, and Brent articulated a lot of that benefit in the previous slides. Lower cost, Brent also touched on that, both in terms of the hardware cost and data pricing, and then lower latency. So we'll walk through some examples here of real-world mission-critical applications, because the reality is there are a lot of cool, and we saw a lot of these at CES, right? Cool internet-connected dog food dishes and fitness trackers and refrigerators and all that, and that's really great. But Digi's hallmark really is we call the Internet of Getting Things Done, if you like. So we're going to talk about some customers in subsequent slides who are using, not in every case Digi technology, but using the kind of technology we're talking about, 5G and up-and-coming LPWAN technology today. All right. So let's talk about speed for a second. Did everyone, there's a comic I think actually said this first, but why is it the only thing that's not HD today are security cameras? Did you ever think about that? Like what could be more important to have viewed in HD than security camera footage, right? It's important enough to put up a camera. Wouldn't it be important enough to see what's going on in that camera in high def? And so Digi has customers today who are using LTE technology for the kind of images that you see below. And so it's very, very, very fascinating to see what they're able to do and the extent to which they're able to expand their business. Because if you go into a sale with, let's say, an owner who owns a chain of auto dealerships, and you show an image on the lower right and say, see, we can help protect you from theft, someone stealing cars or stealing the alternators out of the cars, and you show them this image, what do you think your success rate is going to be versus showing an image with the clarity on the left, right? So I'll give you sort of one guess as to which one is sent right over LTE. This isn't to say that universally LTE is required for any kind of security camera applications. That's certainly not the case, but we see that trend certainly going forward as LTE Cat 6 and as 5G it becomes available. So this is an example that Brent had referenced sort of in the sort of anonymized. This is an example where we worked with GE to do some tank monitoring. And so the example on the left is representative of that sort of certainly still going on today, but especially prevalent in the early 2000s, late, coming up to 2010, mesh networking to a 3G gateway, right? So I've got some level sensors on, let's say, a water quality or a fluid process treatment kind of application. I need to know the tank level and some metrics related to the contents of that tank. I can have an expensive, relatively expensive, upfront capital cost, complicated mesh network, possibility of failure. Brett mentioned someone building a metal shed or putting up a chain link fence or something like that, and really altering the RF network. Then back to a gateway with a single point for takeout. Or, as Brent had given the example, I can put a monitoring device on each individual asset. So I can put, in this case, a Connect tank type of specialized LTE connected device right on the in this case, I'm saying a diesel exhaust fluid tank. But so this is simple. It's relatively actually much easier to install, less prone to failure, and with new data plan pricing and cellular costs coming down, we do expect to see more of these discrete point-by-point monitoring type of applications. Okay. So the other example is a lottery operator called IGT, what used to be GTech. You may know them by both names, but companies like IGT, and there are a few of them in the world, they historically had faced a trade-off between, say, in the early 1970s up into the 2000s, they're primarily connected by a USB dongle, and the text is a little bit cut off there, but there's, or V, right, very small aperture terminal, so a satellite terminal. And so fundamentally, these gaming operators faced a choice, right? They could take a relatively high cost, high reliability approach on the upper right of that XY axis there on the left, and you can install a VSAT terminal at each location, the convenience stores, liquor stores, and so forth. Or they could take a lower cost and relatively, actually much lower reliability approach with USB dongles, if you like, or a USB-based 2G or 3G connection. So for a company who faces very high SLAs, service level agreements, in order to win their contracts, in most cases, well, certainly many cases, they chose VSAT, right? I would say in most cases they chose VSAT. Take the high cost and high reliability approach. But with the prevalence of cost competitive LTE and highly reliable LTE, that old binary choice is now obviated, and what we see today is lottery terminals are connected over LTE in many, many tens of thousands of instances, because this gives the lottery operators a low cost, highly reliable LTE connection. So this is extremely attractive, and this is really this kind of trade-off dynamic is what's driven the adoption of LTE in many retail applications beyond just lottery operators. Think of many, many kinds of retail terminals now connected over LTE. So that's a very sort of clear-cut, real-world example of the cost making a difference. Okay, so the better connected, though we also mentioned better connected means lower latency. All right, and I'll briefly touch on two examples related to lower latency, and then we'll get to some questions. So this is an example of this is in particular, I'm thinking of a gas utility in the southeast United States who has used 2G, 3G, and now into 4G LTE networking for their SCADA controls group, if you like. They have a gas distribution pipeline, and they need to pull things like flow, essentially metering, SCADA type information. They originally used a copper sort of DS0 circuit, which pretty low latency really. But when they had gone to 2G and 3G, their experience was slow. Coverage can sometimes be spotty. Frequently, they need to do PRL updates or some kind of respond to some kind of networking change from the carrier. Their experience with LTE, and this is a direct quote, is it's like you're right there. They can sit in their control room and make changes, view data coming by, and it's very snappy in terms of response. They have to do fewer PRL updates. Coverage is better, as partly due to networks being built out. But so low latency really, really matters in a SCADA type application, and that's Brett had mentioned the trade-offs between latency and cost. That's certainly something to keep in mind in this kind of application. Okay, so we'll talk about a freight train example, and this is from a Canadian freight rail company. Lower latency matters when you are trying to send information to and from a train. So here's an example of when I would suggest latency really matters. So we'll do kind of a thought experiment here. So you have a freight train weighing about 3 million kilograms. Okay, it's going down a 2% gradient. That would be fairly common. It's going 96 kilometers per hour, 60 miles per hour. That's, I think, the speed limit for a Class 4 rail. Okay, so if you have, and I know there are other forces at work, friction and drag and so forth, but just holding those aside for a second, think about this freight train that's fundamentally representative of about 13,200 kilonewtons of force. Okay, so how much is a kilonewton? If any of you have like a carabiner on your keychains, a climbing carabiner, you'll see a little KN note there. A kilonewton is about 225 pounds of force for our non-metric audience. But so 13,200 kilonewtons is a lot of force. In fact, the Space Shuttle rocket had two boosters that each did about 12,500 kilonewtons. So that freight train is creating about so basically an engineer who's trying to slow that freight train down is trying to slow down half of the Space Shuttle rocket, right? So that's like a lot of force, right? And so how do you do that? Well, did you know that the way that you do that is the freight train fundamentally needs to receive a braking algorithm. So the engineer will receive a file that says, hey, here's how to brake. And I don't know the technical sort of math further on behind how that train brakes, whether it's just the engine or whether there are brakes on subsequent cars. But the point is that if you were engineer in charge of a freight train that was basically half of a space shuttle in terms of power, you would want a really reliable, really quick connection, right? And so this is a case where latency really, really matters because you are going down a hill with a rocket essentially, and you need to stop. So in this particular case, is a very specialized LTE device that's used. It's very specialized, very expensive, but this is, I would submit to you, this is using the public LTE networks today. Okay, so let me just conclude. I know we said we'd leave some time for Q&A, and I think we're on a pretty good track to do that. So bringing it back to the original analogy we used, thinking about the future, do you plan to drive on the freeway or the shoulders? Okay, so if you or your customers or your partners are freeway type application folks, okay, you need to be thinking about high performance CPE. It may not be best to have the first LTE advanced cellular router, for example. It may be best to have the most powerful LTE advanced router in order to take advantage of LTE Cat 9, for example, or for future advances in that network. You want to look for solutions from vendors who provide visibility into link quality. There's some interesting improvements in link quality analysis that you can do in terms of metrics, latency, packet loss. Look for those kinds of solutions. And then just sort of reiterating what Brent had said, if you're driving on the shoulders, okay, if you're in the Cat 1, M1, narrowband IoT sort of application set, you need flexible power options, right? You need it because it may be power sensitive or it may not be. And you need the ability to manage that power setup. You need machine language support. So do I support Modbus, wired hard, simple, say RS-45 or something. And then finally, you want to look for vendors with apps that support new field use scenarios. Brent was talking about installing tank level sensing on discrete tanks versus mesh networking back to a gateway. That's fine for a company to develop solutions that can do that, but have they gone the next step and then created configuration provisioning apps to support that. So, Robin, those are all all the slides that we'd wanted to cover, and I suppose we could open it up for some questions now.
That's great. Thanks very much. Okay, so we'll move over to some questions. We've got quite a few questions in, but if you can send any that you have now, then we'll aim to respond to those as soon as we can. Initially, so you mentioned new applications in that last slide, in fact, new applications in support of field use scenarios. Do you have any examples of that?
Yeah, we do. Brent, I would wonder if you would just talk a little bit about the Connect sensor and the app that we built for that.
Yeah, so I think with the app, so there's ability when you do these industrial IoT applications, you need the data remotely, but you also occasionally need it locally. And when we mentioned the app, we were talking about some new capabilities of pairing a mobile app over Bluetooth to talk to these industrial devices for the technician who's on site versus potentially the system engineer who's remote. And they will typically need different information. They need it at different times, and there's potentially different permissions and security levels for each of those people. So pairing a Bluetooth application for local use versus a cellular for remote access to that data really gives you a powerful platform in that.
That's right. Okay, yes. All right, well, then the next question is, there have been a few questions comparing different, or trying to understand the difference in data rate between different CAT levels. So I don't know if you can say something about that, but specifically, how does Cat LTE Cat 1 compare with Cat M and MB-IoT?
Sure, I can take that. So LTE Cat 1 is available now. LTE Cat 1 is essentially 3G type of speed. It's a scale down from typical LTE. It does not have the power saving modes that you will get in the two narrowband standards that I mentioned. but it does bring down the cost of the module significantly. So I view LTE1, which again is available now, as kind of the first time you could put LTE in a machine-to-machine product and not price yourself out of the market because you really didn't need LTE. LTE Cat M then drops down to 2G speeds, and that's where you start seeing the power-saving modes. And narrowband IoT is sub 2G speeds. It's sub 100 kilobyte per second, and increased battery life. So that's kind of the progression of the different networks.
Okay. So another question here: does NB IoT include a paging facility? So where the network wakes up the sleeping devices by sending paging messages or something similar?
It does. I don't know if I'd call it paging, but when you go into what's called the discontinuous reception mode, each one of the two is going to wake up. I think for Cat M1, it's like every 5 seconds. For NB, it's 10 seconds. And it's going to check for traffic. In between those times, it's typically unreachable because you're off. You're not listening to traffic from a module perspective. So the paging would be when it wakes up and looks for data on one of those receive channels. Right.
Okay. And what's your view about adoption of Cat M1 versus NB IoT by service providers in North America and globally? Considering both technically and business-wise, which one are the chip vendors more keen upon? I think you covered that to some extent in looking at the different regions and the different mobile operators.
Yeah, in the U.S., it's definitely going to be Cat M first. It's unclear, when will narrowband IoT follow? Will it follow? Globally, outside of the U.S., the carriers seem to be driving more towards narrowband IoT. Definitely in Europe with Vodafone, the same with Australia and Asia. They seem to be driving more towards the NB IoT. And does that mean that they will eventually do Cat M, or they skip that entirely? I don't know.
Would you say there's a particular reason for one adopting Cat M and one adopting NB IoT? Is there sort of different view about the types of applications that are going to be required, or is there a particular reason for that you're aware of?
No, I think each carrier is kind of making their own decision. They have different reasons for doing. The Cat M is probably a little bit of an easier adoption based on what's out there in the market today, or what's deployed on the towers with LTE, let's say with narrowband IoT. I think it mainly looks more at the use cases they're looking at. I think a lot of people think that narrowband IoT will greatly expand the number of battery-powered devices out there because it is so low power and so low cost.
Do you think that it's going to be possible to put LTE-M and NB IoT into the same module?
Yeah, I think you would be able to do it in the same module. It's more a question of how many different bands would you have to support based on your global coverage.
I see. Yeah. Okay. All right. And then have the carriers provided any information on pricing plans, use parameters, and so forth?
From my perspective, I haven't seen a ton of things locked in stone yet. Andrew, I don't know if you've...
No, it seems to be talked about quite a bit, and it escapes me. I thought we'd seen something sort of preliminary from AT&T, but it's nothing that's publicly sort of promoted that I've seen.
No, that's fine. That's fine. Okay. So there's one here that I think is looking to understand how it actually works in intelligence terms. So where will the IoT intelligence, i.e. the application, typically reside in the LPWAN market, inside or outside the narrowband cellular device, or both? I think this is just trying to understand how it works at a low data rate.
I can kind of, so in general, and it's always going to depend on the use case, as you get lower and lower power, you've got lower and lower processing, so you've got typically less intelligence on the edge and more intelligence in the cloud.
Right.
It's all about getting the data up to the cloud as inexpensively as possible. Andrew, I don't know if you...
No, I was going to say the same thing. I think the other notion to bring up in terms of where the intelligence is would be sort of to take a security angle on it, or to given that there may be limited power, limited processing, limited memory on the edge, I think there's also the notion that there's limited ability to defend against security threats potentially. And so, like you said, getting the data to the cloud in a safe and reliable way is the most important thing. I know we talk a lot about intelligence at the edge, and you hear a lot about that, but we'll have to see. And like Brent said, it depends on the application.
Okay. A very quick one. What is a PRL update?
Oh, what is it, Brent? Preferred roaming list?
Yep.
Just a
right.
Yeah, it's essentially telling the module who the roaming partners are.
Okay, all right. And when do you expect Cat-M or NB-IoT to be more or less ubiquitous? When do you expect it to really take off? I think is probably a better way to say that.
Brent, you're closer. You should comment on that.
Yeah, I can comment on that. So I'm going to give you the Digi answer, which maybe is not the answer you get if you talk to a carrier. I think it's going to start to really take off late this year. The carriers are going to have a lot more, at least in the U.S., the carriers are going to have a lot of networks up. They're going to be promoting a lot. But when you think of the chain of events that have to happen to really what you consider ubiquity, from my perspective, the network has to be live, and you got to have devices you can use on it. And you think that the network has to go live first, then the module vendors have to go through their certification, and then the device vendors have to go through their certification. So there's kind of a 2 to 3 month lag each step along the way. So I would be surprised if you would really see a massive rollout before maybe late this year, even though the carriers will likely advertise their networks are going to be live before that.
Right, okay. And then talking a bit about battery life here, the 5 to 10 year battery life for M1 and NB-IoT, is that just the radio or the end application like a sensor reading every 10 minutes? I think a little bit more explanation about what that is, that battery life, what that covers would be helpful.
Yeah, I guess, so everything's relative on that. It's how often you're reporting. I use that as one of our products, the Connect sensor. Typical use of that is reading data 10 to 20 times a day and reporting that data 1 to 2 times a day, and that's going to give you about a 2 to 3 year battery life. If we look at that same use case and swap out only the cell module and move that to a Cat-M and then eventually to a narrowband IoT, that's a relative battery life improvement you would see with that use case. But I know with that product, we see customers who are reporting 24 times a day. Well, they're going to be more on the 6 to 9 months battery life, and others that are extending it out over a few weeks, and they might see 5 to 7 years on their current LTE technology. So it's all relative based on how you're using the product.
Okay. Interesting one here. Will these new Cat-M and NB-IoT use regular SIM cards?
Yes, although I think you'll see more of a move. When you say regular SIM cards, you'll see much more of a move to the embedded SIMs as we go forward. I guess I'm not 100% positive of how the technology will support that, but I know generally in the market, you'll see more and more moves to embedded SIMs versus the standard kind of SIM that shows up in a credit card format.
Okay, all right. So I'm personally, I think that there'll be much more use of embedded SIM, as you say, with these, because it's more automated that way. But let's see how that pans out. Do the current M2M management platforms need to be upgraded to work with these new technologies?
Yeah, that's a good question. I'll give a take on that, Brent. You can chime in. It seems to me that there will be, so upgraded can mean a lot of different things, but it seems to me that to the extent that a new LPWA technology provides insight into what's going on at the network level, at the physical level, in terms of, I mentioned earlier, RF quality, packet loss, latency, so forth. If there's something interesting that LPWAN technology can tell a management platform about what's going on in the field, then that management platform would need to be upgraded to take full advantage of that. That's how I would approach that. What would you say, Brent?
Yeah, I think the biggest, I agree with what you said. I think it's the management platforms understanding that these devices are not always reachable. And things like timeouts where I didn't get a response versus in this amount of time, when you get to those lower power, higher latency devices, that might break your system. And we see that as we look at our router products, which are connected all the time, versus our battery-powered IoT products, which connect very rarely. The management platforms can handle it, but sometimes the mentality of the user can't because they expect things to be connected all the time, and that's just not going to be the case with the battery IoT products. And that might be the case with certain, even like SCADA systems that expect a device to be connected all the time, and if it's not, they error out. So I can see some updates required in those type of systems.
Okay. Then you briefly mentioned unlicensed band alternatives, Sigfox and LoRa. What future do you see versus Cat M1 in the U.S.?
Mm-hmm. Yeah, I know, Brent, you're closer to Sigfox. Why don't you comment on that?
Yeah, in fact, we did. Robin and I did a webinar just previously with Sigfox as well.
Yeah.
So Sigfox is a different standard. It's really extreme. You know, when I say low cost for Cat M and narrowband IoT, that's really relative to what LTE has been in the past. Sigfox is really the extreme case of low cost, and you know, there's additional trade-offs with that. Is that I believe that most of the data is unidirectional. You're extremely low byte rates as far as transmitting. So there's definitely use cases from an ROI perspective that Sigfox could support that cellular never really could. I don't really see those two as competitors. LoRa, it does kind of tread into the same space as, especially maybe like the NB IoT. I'm not a LoRa expert by any means. I just see it from a very high level that those do become somewhat competing standards as far as the capabilities that they provide.
So you would see Sigfox as being pretty much complementary to Cat M1?
Yeah, I could see those being complementary,
Okay.
or you know, and they can also exist on their own too. There's use cases for monitoring where you need an extremely low cost per asset point that Sigfox can meet that no LTE standard could.
Okay, all right. Well, we're almost out of time there. So before we go, I'd like to thank our audience for joining us. We really appreciate the time you spent with us. And now I'd like to hand back to David at the M2M Zone for some further announcements. Thank you.
Yes, on behalf of the M2M Zone, thank you, Robin, Andrew, and Brent, and thank you all for joining us today. A recording of today's webinar will be available within 48 hours on our website, m2mzone.com. Just watch for your post-event email, which will include a link to the web page. Thank you, everyone.